AsapMath.
Hello everyone, in this video we are going to talk about divisibility rules of numbers between 2 and 20. For easiness, we will group the numbers into different sets. Set 1 consists of numbers 2, 4, 8 and 16. This set exhibits a similarity. All numbers are powers of 2. Moving on to first set. First number is number 2. If the last digit of a number is divisible by 2, then the whole number is divisible by 2. Let's consider a few examples. Here, last digit is considered. 2 is multiple of 2, so 32 is divisible by 2. Moving on to next number. If the last two digits of any number is divisible by 4, then the whole number is divisible by 4. We will consider few examples. Here, last two digits are considered. 28 is multiple of 4, so whole number is divisible by 4. Fifty is not a multiple of 4, so we can conclude that whole number is not divisible by 4. Next number of this set is number 8. If the last three digits of any number is divisible by 8, then the whole number is divisible by 8. Here we have to consider the last three digits. We want to check whether it is a multiple of 8. To make it clear to you, we will use the long division. The result shows that it is a multiple of 8, so we can decide the whole number is divisible by 8. We will consider another example. Last number is 16. If the last four digits of any number is divisible by 16, then the whole number is divisible by 16. Here we have to consider the last four digits. We want to check whether it is a multiple of 16. If it is a multiple of 16, then whole number is divisible by 16. As it is little bit difficult, we will use the long division to analyze this. It shows that it is a multiple of 16. So, whole number is divisible by 16. Let's go to the set 2. It consists of 5 and 10. Number 5. If the last digit of any number is either 0 or 5, then the whole number is divisible by 5. We'll see few examples. This is very easy to check whether the last digit either 0 or 5. Moving on to next number. Number 10. If the last digit of any number is 0, then the whole number is divisible by 10. We will consider few examples. Third set, consider of 3 and 9. If the last digit sum of a number is divisible by 3, then the whole number is divisible by 3. Addition of every digit is taken. Now we have to check whether this is divisible by 3. So it seems okay. Digit sum is not divisible by 3. So whole number is not divisible by 3. Next number is number 9. If the last digit sum of a number is divisible by 9, then the whole number is divisible by 9. Again, the addition of every digit is taken. It is equal to 18, so it is divisible by 9. Digit sum 24 is not divisible by 9. So whole number is not divisible by 9. Set 4 consists of 6, 12, 14, 15, 18 and 20. First, we will consider number 12 to build up a logic of this. In this method, we have to find the factors of 12 without common prime factors. Here, 3 and 4 don't have common prime factors. So we can conclude that if number is divisible by 3 and 4 both, then number is divisible by 12. We will consider few examples. 60 is divisible by 3 and it is also divisible by 4. So we can conclude that it is divisible by 12. 450 is divisible by 3. But it is not divisible by 4. So it is not divisible by 12. Now we are moving back to 6. If a number is divisible by 2 and 3, then the number is divisible by 6. Consider few examples. 36 is divisible by 2 and it is also divisible by 3. So it is divisible by 6. More examples are listed. Next number is number 14. Here factors to be considered are 2 and 7. So if number is divisible by 2 and 7 both, then number is divisible by 14. But we didn't discuss yet how to find the divisibility of 7. Let's consider that later. We'll consider few examples. 70 is divisible by 2 and it is divisible by 7 also. So 70 is divisible by 14. This is divisible by 2, but this is not divisible by 7. So 166 is not divisible by 14. Moving on to 15. Here factors to be considered are 5 and 3. So if a number is divisible by 3 and 5 both, then it is divisible by 15. It is divisible by 5 and it is divisible by 3. And 90 is divisible by 15. It is not divisible by 3. So 770 is not divisible by 15. Last number of this set is 18. Here the factors to be considered are 9 and 2 because they don't have a common prime factor. If a number is divisible by 9 and 2 both, then the number is divisible by 18. Ninety is divisible by 9 and it is also divisible by 2. So it is divisible by 18. This is divisible by 9 and it is not divisible by 2. So 279 is not divisible by 18. Set 5 consists of 7, 13, 17 and 19. Here last digit of number is multiplied by a number and the product is either subtract or added to the truncated number. So most important things to be identified are identification of number used to multiply and whether addition or subtraction. First we'll go to the number 7. Subtract 2 times the last digit from the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 7, the original number is also divisible by 7. Here are some examples. Here last digit is 7. So it is multiplied by 2. Answer is 14. It is subtracted from the truncated number. So result is 0. 147 is divisible by 7. We will consider another example. Here last digit is number 1. It is multiplied by 2. Answer is 2. It is subtracted from the remaining number. So answer is 693. Then the process is again repeated. Now the last number is number 3. It is multiplied by 2. Answer is 6. When 6 is subtracted, the answer is 63. It is divisible by 7. Then the whole number is divisible by 7. Let's go to the number 13. Here add 4 times the last digit to the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 13, the original number is also divisible by 13. Last digit is 5. It is multiplied by 4. Answer is 20. It is added to the remaining number. Then the answer is 39. It is divisible by 13. So whole number is divisible by 13. Now we'll consider more examples. Last digit is 2 and the process is repeated. "39 is divisible by 13, so the whole number is divisible by 13. Move to number 17. Subtract 5 times the last digit from the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 17, the original number is also divisible by 17. Last digit is 5. 5 is multiplied by 5. Answer is 25. Then subtract it from the remaining number. Answer is 17. So the original number is divisible by 17. Another example is listed here. Last number is 19. Add 2 times the last digit to the remaining truncated number. Repeat the same step as necessary. If the result is divisible by 19, the original number is also divisible by 19. We will consider few examples to understand the concept. Here, last digit is 2 and it is multiplied by 2. Then answer is 4. It is added to the remaining number. Answer is 19. So it is divisible by 19. Then whole number is divisible by 19. Let's go to another example. Last set consists of number 11. A number is divisible by 11 if the difference of sum of digits at odd places and sum of digits at even places is divisible by 11. Here we need to identify odd places and even places. Sum of even positions are taken. It is 8. Sum of odd positions are taken. It is also 8. Now we have to take the difference. It is 0. This is the multiple of 11. So, whole number is divisible by 11. Moving on to another example. Sum of even positions. It is equal to 10. Sum of odd positions. It is equal to 21. Now the difference of two sums are taken. So we can conclude that whole number is divisible by 11. This video is a bit long video. Here we discussed easy tips to identify whether any given number is divisible by numbers between 2 to 20. Practice the methods discussed in the video and then you can amaze your friends.
Thanks for watching. If you like this, make sure to subscribe for more.